Okay, we're still finding areas between curves here, and this time they give us the curve y equals x squared minus 4. That's a parabola, translated 4 units down, so it should start out looking something like this. So that's our parabola. It has a y-intercept at minus 4. It has an x-intercept at minus 2 and another one at positive 2. And I'm actually going to flatten this out a little bit because we need a bit of a wider diagram. Because the other line that comes in is the line x equals 4. That's a vertical line, and it lies over here. It's a line that goes through 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, so it goes straight up and down. And our parabola will meet that if I extend it out far enough. Forgive me if I cheat on the curvature a little bit. So the area they're interested in is this area, which is above the x-axis and bounded by the lines x squared minus 4 and x equals 4. So that section there is what we're after. And we know that an integral can help us find this. It'll have a dx on the end because they always do. What are our heights here? The top of this region is x squared minus 4. And what's the bottom, or do we need a bottom? This is actually the kind of integral that we were doing in the previous section where we were taking anything that was above the x-axis. So you can think of these rectangles as being just x squared minus 4 high. The other way you can think of it, if you want, if you like the areas between curves approach, is to say x squared minus 4 is the top of each of these rectangles, and this line, which is right at 0, is the bottom of each of these rectangles. If you do that, you're just saying 0 is the bottom of each rectangle, and you can see how this isn't going to affect our expression. But this is how we use thinking from the between curves unit to handle integrals that we did in the introductory unit where everything was off the x-axis. We just say the top is x squared minus 4 and the bottom is 0. In other words, there's no area that we're throwing out that's below this. So there's our integrand. It's just x squared minus 4. I'll write that again to get rid of that cluttery 0. Da, 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 dx. Now what do we have for limits of integration? Happily, we know that this starts at 2. That's where this line becomes positive and where our area begins. So our left-hand boundary is x equals 2. How about the right-hand boundary? Well, they handed us that one also. They said it's 4. 4 is where we cut off. So nothing too bad here. We do an antiderivative. The antiderivative of x squared is 1/3 x cubed. The antiderivative of minus 4 is minus 4x. And we have to evaluate that at 4 and at 2. 4 to the third is 64. A third of that is 64 over 3. Minus 4 times 4 is 16. Minus, and now we do all that again at 2. 2 to the third is 8. 4 times 2 is 8. And common denominator, 64 over 3. 16 is 48 over 3. We have minus 8 over 3. That's already got the correct denominator. And minus negative 8 makes plus 8, also known as 24 over 3. 64 minus 48 is 16. 16 minus 8 is 8. 8 plus 24 is 32 over 3. And done.